Welcome to Math in 10. This is Chapter 1. This is our number relations chapter. So the biggest thing we're working on are, well, really 5 things. We're going to model perfect squares and square roots. We're going to use a variety of strategies to recognize perfect squares. We're going to use a variety of strategies to estimate and calculate perfect squares. And we're going to explain and apply a Pythagorean theorem and use all of these things in problem-solving applications and questions. So here we go. Let's start with what a square is. So really simply stated, a square is just a polygon. It has to have 4 90-degree corners. It has to have 4 sides that are all equal length. And if you want to take the area of that square, you can find that by multiplying length by width. But obviously, because it's a square, length and width are the same. So if I draw a square here, I can just use some tools. And I'll start here. I'll make my square 4 by 4 units. So you can see here that if my square is 4 by 4, I can always find the area of that square. And finding the area of that square, I just need to say area is equal to length times width. And I can then say, well, my area is equal to, my length and my width are both 4, so 4 times 4, and my area is equal to 16. And that would be in meters squared or centimeters squared or whatever unit we're working with. So if we keep that in mind, when we square a number, we're actually really just multiplying it by itself. So for example, literally I can take the number 4 and draw a square out of it, but what that means is it's 4 times 4. So 4 times 4 is 16, or 4 squared equals 16. Now to go backwards from that, to find a number's square root, what you're looking for is a factor that can be multiplied by itself to form that original number. So for the example, if I'm asking for the square root of 9, that means you need to find the factor that you multiply by itself to produce 9, or to make 9 as a product. So we all know that 3 times 3 equals 9, and therefore the square root of 3 is equal to 9. And we write that with a little square root sign, 9 underneath, and that equals 3. Basically, we know that 3 is the factor you multiply by itself to make 9, and that's the definition of a square root. So for a little bit more detail, I'm just going to do a few notes on paper here. So we're going to list all of the perfect squares between 1 and 100. So we'll just start with, well, let's see here. 1 squared equals, well, that's 1 times 1, and that's equal to 1. So the first perfect square is 1. The next one is 2 squared. Well, that's 2 times 2. That equals 4. So the second perfect square is 4. The next one is 3 squared. So that is 3 times 3 equals 9. Perfect square is 9. Next one is 4 squared. That is 4 times 4 equals 16. So the next perfect square is 16. Then we've got 5 squared equals 5 times 5. That equals 25. Next perfect square is 25. 6 squared is 6 times 6. Next perfect square is 36. We've got 7 squared is 7 times 7. So that perfect square is 49. 8 squared is 8 times 8. That equals 64. 9 squared is 9 times 9. That equals 81. And we've got 10 squared, which is 10 times 10 for 100. So you can see all of my perfect squares between 1 and 100 are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100 if I scroll my page down here. All right. We can then go back and also start with our perfect squares. So I'm just going to rewrite these. And what we'll do is we'll take the square root of each of them. So we'll work backwards, just like we did with our definitions earlier. Okay, so we'll start back at the top here. If I take the square root of 1, again, I'm looking for the two numbers. They have to be the same that I multiply together to make the number 1. Well, that's easy. 1 times 1 is 1. So the square root of 1 is 1. If I want the square root of 4, again, I take the square root, and I'm looking for the two numbers that are the same. I multiply together to make 4. Those numbers happen to be 2. If I take the square root of 9, I know that 3 times 3 is 9. Square root of 16, I know that 4 times 4 is 16. Square root of 25, I know that 5 times 5 is 16. Square root of 36, I know that 6 times 6 is 36. Square root of 49, 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. So there we are. We now know how to take square roots and perfect squares. We also know how to find the area if we're given the side lengths of a square. So for example, if I draw a square out here, we'll just make that square maybe 5 boxes by 5, and I'll do the same here. So we know that 5 and 5, those are the side lengths of our square. So in order to find the area, well, area is equal to length times width. In this case, in all the case for squares, length and width are the same, so it's 5 times 5. Area is equal to 25. Now, we can also use that information to go backwards. And what I mean by that is that if we're given a square with an area, we can also take that area and find the side lengths from it. So if I'm just given this same square, but instead I've told that the area is 25, all I need to do is take the square root of that. And by taking the square root of that, we're technically finding what those side lengths are. Okay, I see a lot that students just divide this by 4. They think that's a perimeter. It doesn't work. 25 divided by 4 is not the side length. Okay, it doesn't work like that. You have to take the square root. So let's do another example here. What if I had another one that was 3 by 3? Okay, so I know that, well, area equals 3 times 3. And I can also work backwards. If I've been given that same square with an area of 9, to find the side lengths of that square, I simply take the square root of 9, and I wind up with 3. One more example. Let's say I'm given this square. Okay, and I'm told that the area is 36. Well, what I need to do is simply take the square root of that to find that these side lengths are 6. Fairly simple.